What if your Python program could do 10 things at the same time without using threads? That is exactly what async and await give you. I am Mahaz. Today in episode 18, Async and Await, you will learn how Python's event loop works, how to write coroutines from scratch, and how to fetch 100 URLs in the time it normally takes to fetch one. This is the engine behind Fast API, aiohttp, and every modern Python server. Let's go. Let's start with the problem. In synchronous code, every function call blocks. You call fetch URL, Python waits, doing nothing until the server responds. If you fetch 10 URLs one by one, you wait 10 times. Look at the left card, synchronous. Each request takes 2 seconds. 10 requests take 20 seconds total. Now look at the right card, asynchronous. You start all 10 requests at the same time. While one request is waiting for a response, Python works on the others. 10 requests still take 2 seconds total, not 20. Same network time, 10 times faster. This is not magic. It is the event loop. A coroutine is a special function defined with async def. It does not run immediately when you call it. Calling an async function returns a coroutine object. To actually run it, you use await. Await says, run this coroutine and pause here until it finishes. But while it is paused, Python can run other coroutines. That is the key insight. Await does not block the entire program, only this coroutine. The event loop is free to do other work. Look at the code card. Async def fetch data. That is the coroutine definition. Await asyncio.sleep. That is where Python can switch to another task. Asyncio.run of main. That starts the event loop and runs your coroutine. The event loop is the heart of async Python. Think of it as a task manager that never sleeps. You give it coroutines. It schedules them. When a coroutine hits an await, an I/O operation, a sleep, a network call, the event loop pauses that coroutine and runs a different one. When the I/O finishes, the event loop resumes the pause coroutine from exactly where it left off. Watch the diagram. Task A starts, hits await, pauses. Task B starts, hits await, pauses. Task C runs to completion. Task A resumes and finishes. Task B resumes and finishes. All three run concurrently on a single thread. No threads, no multiprocessing, just smart scheduling. Asyncio.gather is how you run multiple coroutines at the same time. You pass it as many coroutines as you want. It schedules all of them and returns all results as a list. Look at the code. We define fetch as an async function that simulates a network request. We define main as an async function. Inside main, we call await asyncio.gather with 3 fetch calls. All 3 run concurrently. Each fetch takes 1 second, but because they overlap, total time is still 1 second, not 3. The results list preserves the original order, even if task 2 finishes before task 1. Asyncio.gather is your main tool for parallel I/O. Asyncio.createTask lets you fire a coroutine in the background without waiting for it immediately. You create the task, keep doing other work, and await the task result later when you need it. Look at the difference. With gather, you must define all coroutines up front. With createTask, you start a task, do something else, then await the result. This pattern is called fire and forget for background tasks. For example, start a database write, do other processing, then check if the write succeeded. CreateTask gives you fine control over when tasks start and when results are collected. Async Python also has async with and async for. Async with works like a regular with statement, but it can await the enter and exit methods. You use it with async resources like database connections and HTTP sessions. Async for works like a regular for loop, but it can await each item from an async generator. Look at the code card. Async with aiohttp.client session as session. This opens an HTTP session asynchronously. Async for line in response.content. This reads the response line by line without blocking. These 2 keywords are what make libraries like aiohttp and SQL Alchemy async possible. Whenever you see a library with async support, it uses async with and async for under the hood. Let's see async in a real scenario. Fetching multiple URLs with aiohttp. Aiohttp is the async equivalent of the requests library. We define fetch URL as a coroutine. Inside, we use async with session.get of URL. This sends the HTTP request without blocking. We await response.text to get the body. In main, we create a client session, then use asyncio.gather to fetch all URLs at once. If you have 10 URLs each taking 1 second, gather fetches all 10 in approximately 1 second total. This is the exact pattern used in web scrapers, API aggregators, and microservice clients. Install aiohttp with pip install aiohttp. Our mini project, an async URL checker. It checks whether a list of URLs is reachable concurrently. We define check URL as a coroutine. It tries to fetch the URL with a timeout of 5 seconds. If the status code is 200, it prints OK in the URL. If it times out or errors, it prints fail in the URL. In main, we gather all check URL coroutines together. You can check 100 URLs in the time it normally takes to check one. This is a real production tool. Monitoring systems, uptime checkers, and CI pipelines all work this way. You have just built a simplified version of tools like HTTPX and Uptime Kuma. Your challenge: build an async rate limiter. Step 1. Create a semaphore with asyncio.semaphore event. Step 2. Use async with semaphore inside your fetch coroutine. Step 3. The semaphore limits concurrent requests to n at a time. Step 4. Test it. Fetch 20 URLs but allow only 5 at once. Step 5. Print how long the limited version takes versus unlimited. This is a real pattern. APIs have rate limits. Databases have connection limits. Asyncio.semaphore is how you respect those limits while still running as fast as possible. Paste your complete code in the comments. I check every single one. Let's recap what you learned today. Synchronous code blocks, one task at a time. Async code is concurrent. Many tasks overlap on one thread. Async def defines a coroutine. It does not run until awaited. Await pauses a coroutine and lets the event loop run others. Asyncio.run starts the event loop. Asyncio.gather runs many coroutines at the same time. Asyncio.create task fires a background task. Async with and async for work with async resources and generators. aiohttp is the async HTTP client. Use it instead of requests in async code. Next episode, context managers. The with statement, __, enter __, exit __, and context lib. Subscribe so you don't miss it. See you tomorrow. Async and await, mastered. You can now write non-blocking Python that runs 10 times faster. Subscribe for the next episode. Drop your rate limiter in the comments. I am Ahaz. See you in episode 19.